So today our presenter is Austin Little. Austin is a University of Illinois Extension horticulture educator. He covers Jackson, Franklin, Williamson, Randolph, and Perry counties in southern Illinois. With that, I'll let Austin take it away.
Good afternoon, and thank you, Maggie, for the introduction and the helpful info there. And welcome you all back. Hopefully you were able to check out the first installment. And so welcome back today for Green Roofs. Maybe this is a nice break from the heat today to come inside and do a quick webinar. So glad to have you back if you're returning. And so today we'll be taking a closer look at green roofs, and we'll look a bit more about how they work and what they're used for, kind of their purpose in the suite of green infrastructure. And then we'll also look at impacts on the urban environment. So those impacts are social, economic, and environmental in the urban environment. And personally, I think green roofs are kind of the rock stars of the green infrastructure world because they're very trendy in our current time in urban areas and cities. But they are very dynamic systems, so they have a lot of benefits, and they offer a vast range of environmental services and positive impacts on the urban environment. So they're one of my favorite green roof landscape systems, or urban green roof systems, and they're the green infrastructure that I have worked the most with, worked closely with over the years. I started working on the SIUC green roof in 2012, so almost coming up on 10 years of green roof work on the SIUC green roof, and I'm still doing work up there today. So we'll actually have some video of the green roof here and a tour at the tail end of the program today. Okay, so let's do a quick refresher on green roof information and the benefits here. This is just a recap from last week. So green roofs are also known as living roofs, and by definition, they need to have some kind of multi-layered system with vegetation, some kind of medium for that vegetation to grow in, some kind of drainage system, and a waterproof membrane. So those are the things that really need to be there for it to be a green roof. Now there are kind of simulated green roof systems where they're kind of modular trays or even grow bags that are just on the surface of a roof. And in my mind, those are kind of simulated, well, at least the grow bags are kind of simulated green roof systems that are still useful and still offer some of the benefits, but they're not quite this architectural feature that is integrated into a building. So those are more modular. But green roofs come in a range of depths. So extensive is the shallow type, intensive is the deeper substrate type, and then there's kind of the in-between semi-intensive. And extensive green roofs are going to be from 3 inches to no more than 6 inches. And intensive green roofs are really going to be decided by the structural capacity of the building. So a very heavily built structure can withstand a much higher weight load capacity than say a retrofitted green roof like the one at SIU, where they had to do some re-engineering so that it could withstand that weight load capacity. So it really just depends on the structural capacity of the building. And in modern times, green roofs were developed in Germany post World War II. And the original intent was to improve fire suppression in urban areas. But then all of these other benefits started to become realized by green roofs. And those primary benefits are, number one, stormwater retention. A green roof system can catch and recycle and kind of intercept up to 80% of stormwater runoff from a building. They also reduce energy costs for heating and cooling in the summer through evapotranspiration, and in the winter through increased thermal insulation. They have a big impact on the urban heat island effect. So they increase the amount of evapotranspiration, so they're kind of air conditioning in urban areas, and unvegetated roofs tend to have a higher amount or a lower albedo. So the lower an albedo is, the albedo effect, that means it's absorbing more heat. So concrete has a pretty low albedo, and a lot of that heat is going to be absorbed by those materials, not as much as bouncing off. So that's why in some places they tried white roofs, like white painted roofs, to increase that albedo to reflect more of the light back into the atmosphere. So big influence on the urban heat island effect. It can cool cities down. So the big problem with the urban heat island effect is that during heat waves, cities hold on to heat into the night. And when temperatures don't go below 80 degrees at night, that's when you really start to have the dramatic public health issues. So it really reduces the amount of heat that urban areas hold on to. Another big benefit is the increased green space. So that kind of ties into these other benefits. That increased green space allows room for more biodiversity, which is something that urban areas are lacking. And it also increases space for urban agriculture. So again, space is limited. Green space, open soil space is pretty hard to come by. It's a high-end commodity, so high-end real estate there. So this increases that space for green space and urban agriculture. Also, another health benefit, public health benefit, is the reduced noise levels. So noise pollution in cities is another health concern, and greening vegetating roofs can reduce urban noise pollution by up to 40 decibels. So that's a big impact. Okay, let's look quickly at the history of green roofs. So green roofs have been used since ancient times, and documented use goes back to pre BC times. So with the Hanging Gardens of Babylon in about 500 BC, those were early green roof systems. They had a layered kind of irrigation system and in medium. And so those were one of the wonders of the ancient world. So those were some of the earliest documented examples. And then Scandinavian peoples have been using green or sodded roofs since the Middle Ages, or maybe even before that, on their homes and their other structures. And that offers insulation again. The main reason that they were doing that was the insulation value, staying warmer in the winter. And so that brings us up to the modern adoption of green roof technology. So modern green roofs really, again, started to pick up speed in Europe in the mid 20th century. There were kind of some singular examples out there. There were some limited examples out in urban areas. There were a few famous ones. There was a famous one in New York in the 30s. But those were kind of rare. It was more of a rare kind of, more of a unique kind of thing then, and they weren't quite as widespread. So maybe a bit of an oddity before, but now they've really gained momentum, and green roofs have become more and more popular in the United States, starting in probably the 70s. That's when we started to get a few more green roofs happening. So they were still maybe a novelty in the 70s, but starting in the 80s, 90s, they really started to pick up speed. And by the year 2020, modern day, the city of Chicago has probably now more than 509 vegetated roofs, and that comes out to almost 5,600,000 square feet of green roof coverage. So I think they still hold the record on the most square footage of green roof for a city. I don't know if the other contenders would be New York and maybe San Francisco and Seattle, but I think Chicago is still in the lead. And let's talk a bit more about the different types or categories of green roof systems that are out there. And again, extensive, intensive, and semi-intensive are what are going to be kind of the range for the more built and permanent kind of green roofs. So here we can see the extensive green roof. It's about 3 to 5 inches at its deepest point. So it just kind of ranges here, but 5 inches would be the maximum depth of the medium there. And that's at Southern Illinois University. And so then we have an example here of an intensive green roof. So you can see the difference there. This is a rooftop, but they've got trees. I mean, you know, everything. They've got the whole range of deciduous and evergreen trees, turf, all kinds of shrubs. Everything's going on up there. And so this building is heavily engineered, a very strongly built structure, and it probably has a couple feet deep soil in some places, or medium. It would probably be medium again, but if the structure is able to hold that amount of weight, then you can really take it to the limit there, so to speak. And then there are a lot of different modular trays or kind of cell systems. So these trays are going to be grown at a nursery, pre-grown and propagated at a nursery, and then they're installed in like a kind of a tiled grid. So this is going to be kind of the most like low, kind of low initial kind of input there, and input on kind of the labor part of it anyway. It's going to be the easiest to install, really. These are going to be a little bit more complicated, the more kind of layered architectural features here that would be like extensive and intensive green roofs. But the modular cells are kind of a quick plug and play way to get a green roof going, and there are lots of different models and versions of those on the market. So, and those cell trays offer something kind of unique, that they're able to be installed on steeper sloping pitched roofs than can be the extensive or intensive green roof. So there's a limit to how steep an extensive green roof can be on a roof. It probably would need some kind of infrastructure or grid on a typical home roof, and that's where these modular cell packs can kind of step in and have a usefulness there. And here's a nice chart of kind of just a quick rundown of the different features of extensive and intensive roofs. So real quick, the main purpose of extensive roofs are usually going to be functional. So we'll talk about the difference between functional, more utility kind of green roofs that are more for the environmental and economic benefits, as opposed to amenity kind of green roofs that are used for leisure and outdoor living space, kind of activity, things like that. So more park-like amenity open to the public. And those are usually going to be more intensive roofs, and they can be functional, but more often than not have that amenity feature to them, and increased living space. And so structural requirements are going to be about 150 to 350 pounds generally for extensive roofs. That's what the structure needs to be able to support. Now, the green roof at SIU, I think, is on the lower end. I want to say it's around 150. So intensive roofs, on the other hand, can go anywhere from, at the lower end, maybe a semi-intensive green roof would be 500 pounds per square foot, up to, I mean, it's kind of, once you get up to something like Millennium Park that we'll look at, it's really, you can just kind of put as much on there as you want. But generally 2,000 pounds, 1 ton per square foot is about, you could just put about anything on that. And the substrates are going to be lightweight, high porosity, low organic matter for extensive roofs, while intensive can use soil, more organic matter, lightweight to heavyweight. So it's really up to the imagination there. And the depths for extensive are going to be somewhere between 3 to 6 inches, but generally they're not going to be any deeper than 6 inches. And while intensive can go 2 feet or more, a foot to 2 feet or more than that. And the maintenance is going to be lower maintenance. If we're just doing like a sedum or kind of green vegetation cover, there's no mowing or things like that. Now, when we get into more diverse plant material, obviously that's going to increase our maintenance level. And irrigation is going to, in the case of the SIU green roof, we use drip line and timers, so automated irrigation, and any kind of irrigation system you can think of would be on an intensive roof, including drip tape, those kind of things. And then kind of a general baseline for costs. General estimate is anywhere from $10 to $30 per square foot for an extensive green roof. And intensive is going to be 20 or more. And so again, accessibility, usually extensive roofs are more for the functional kind of side of things, but still need to have access for maintenance. And if you're using it for any kind of research, like the one at SIU, now intensive is usually going to be more for public access. So that really is kind of the basics of these two categories. And we're going to look at some examples here of some intensive green roofs, some really kind of stunning and exciting green roofs out there, some really standout green roofs out in our cities. And so one of my favorites is Millennium Park, and every time I go to, this is the main reason I go to Chicago, is this area, Millennium Park and the Art Museum. And so this is a shot of Millennium Park here. Now over here, this is kind of Millennium Park proper. And then once you go across this neat bridge over the freeway there, you're in another park. And I'm blanking on the name of that park, but there's still some green roof infrastructure there. The main kind of interesting point about Millennium Park is that the whole thing is a green roof. And so which one do you think is before or after here? This would be prior to the development of Millennium Park in the 90s. So this was all a big parking lot, and there still is parking structures underneath Millennium Park, but that was built with the intention and purpose built for the Millennium Park being over the top of that structure. So if you didn't know that was technically a green roof, you really wouldn't know, because they've really created this whole green space environment, a park-like environment. So it's probably one of the largest green roofs in the world, and was completed in 2004. Okay, another really outstanding green roof here is the High Line in Manhattan, New York City. And it was completed in 2009. And so it features both intensive and extensive sections of the High Line. And it's just a symbol of sustainable development. It's really a symbol of sustainable success for New York City. And it's really a must-see location to visit if you get the chance, if you're in Manhattan. And it's a repurposed train line that was kind of a blight. It was kind of urban blight that they repurposed into this amazing public park area, and it's about 1.45 miles long, so it might be the longest green roof in the world. It might hold that record. And here we have the Brooklyn Grange. It's in Brooklyn, and there's a few different locations. So this is not just on one building; it's on several green roofs. And I had the chance to take a tour, but I was at a conference and I had to do something else. So I wasn't able to check this one out. It's on my list, but it was completed in 2010, and over the several locations, it covers 5.6 acres, which is amazing, really impressive. And they're all intensive urban agriculture roofs for urban agriculture. And so they produce over 80,000 pounds of organic local produce each year. I mean, that is just, that's really significant and really impressive. If you think about how much produce you get out of your backyard garden compared to this, it's really significant and quite impressive. And these are, if you're in the area, they give periodic tours, so you can sign up for a tour to check out the Brooklyn Grange, and they even have tastings and kind of a dinner kind of included in that. I'd recommend that. And then let's look at the semi-intensive green roof. So this is going to include, it's a range from extensive all the way to intensive. And this is Chicago City Hall green roof. It's one of their standout green roofs, one of their earlier green roofs, completed in 2001. Started planning in 1999, I think. And it ranges from the average depth is 8 inches of medium, but it ranges from 5 to 25 inches at the deepest part of it. And so, interestingly, it was funded by a settlement with ComEd. So that's the big utility and electric energy company in northern Illinois. So that's where that fund. I just think that's interesting that they were able to take that settlement, whatever that was from, for the use of a green infrastructure. So good use of that funding, I would say. And so part of an EPA study was involved with the installation of the Chicago City Hall green roof. It was one of the main first kind of uses of the green roof was for this urban heat island effect research that was really kind of a groundbreaking research study. And it was one of the first big purposes of the Chicago Hall green roof. And so it soaks up up to 75% of rainwater on its surface, and the estimated annual energy reduction in energy costs are $5,000 annually. And so now let's kind of look more specifically at the SIUC green roof, which we'll take a little video tour of. So the SIUC roof was installed in 2010. It's about 2,500 square feet, and the project, the general cost of it was $40,000 for the whole installation. And so this project was paid through with grants from SIU and also donations from several green roof industry companies in Illinois. And they also donated some labor from their companies. And so it was also mainly installed by student work. So student volunteer work, and it was also part of landscape design classes that Karen Midden taught. So Karen Midden was the landscape design professor there that was really the initiator of this, of pretty much all of the green infrastructure at SIU. And so it's estimated to have a 25 to 50 year lifespan. And so now we're at the 10-year mark and it's still going strong, which I'm happy about because I use it quite a bit for my own work. And so this is a kind of a model of our green roof and the layers here, how it's put together. So we have the existing flat or sloped roof here, that's one. And it is often pre-existing with a waterproof membrane. So for retrofitted green roofs like this one, there may need to be some reinforcement to support the added weight, and it may need to have some improvement on that kind of substructure. And then we have the waterproof membrane, and it's the bottommost layer of the green roof here, number 2. And it's the kind of that critical separation between the substructure of the roof and the rest of the layers up here to prevent any kind of leakage. So due to the excessive water amounts associated with green roofs, that membrane needs to be extremely resilient to support the weight of the extra water or snow or materials up there and be resistant to leaks. And so far in 10 years, we haven't had any leak issues so far, so knock on wood. And then we have the membrane protection, and that's going to be an extra layer of plastic usually. Sometimes there will be an insulation layer under that. This is American Hydrotech, kind of their setup, but our roof does not have that. But you can have a couple inches of styrofoam or some other kind of insulation material underneath your drainage tray. So this drainage tray is really one of the most critical parts of this whole system because it holds on to water that drains through the medium here. So this medium is very lightweight and doesn't hold on to water for very long. So we need a catchment system to kind of retain and allow that water to be pulled back up into the root zones of our vegetation here so that we can use as much of that water up before you lose it to the drainage systems. or to the building's drainage stormwater systems. So underneath, or above rather, above the drainage tray here, we have a root barrier, and this is kind of a thick landscape fabric, so that the roots aren't growing down into our lower areas here and causing issues where it may even cause problems with the impermeable membrane here. So we want to keep the roots in this area. We don't want them clogging up our drainage tray. Then we have our growing medium, and the SIUC green roof used an extensive green roof medium, and that's a GRM, which you'll hear me use a few times. And it was donated from Midwest Trading Company, I believe. And so the GRM is typically a mix of medium, usually for extensive roofs. However, some intensive roofs use it. So it's primarily mineral based on various sizes, particle sizes, and it's usually expanded shale clay. So it's like if you think of like puffed rice or like a volcanic rock, it's got a lot of air pockets in it. So it's very lightweight, and it's kind of flash heated to puff it up. And that's primarily the main ingredient there. It also has around 4 to 5% organic matter. Originally it did. Now a lot of that's probably been broken down by now, but what does happen is roots also add organic matter over time. So over the years, we do need to keep an eye on how much carbon and plant material ends up turning into organic matter in that soil as plants either go dormant or die if they're annuals, and all of the extra plant material that plants drop and recycle and add to the environment, that's still happening on the roof. Originally, though, we added in 4 to 5%. I think it was sphagnum peat moss in there, but by now a lot of that has been replaced by the decomposing of plant material. And at the time, 2 pounds per cubic yard of slow release nitrogen fertilizer were also mixed in with the aggregate. So that would be something like a polymer coated kind of slow release fertilizer that was mixed in there. And so we still will broadcast some kind of slow release fertilizer in the spring on just kind of the ornamental things up there. So that's the construction. Now let's look at quickly some green roof cost benefit, and maybe a really brief look at cost benefit analysis. So in general, green roofs can be initially a costly undertaking, a costly investment, but over time can be an extremely valuable investment over the lifespan. And that's if proper planning, design, and a proper ongoing maintenance plan are in place. So you really have to plan for 25 years out. And that can kind of be the downfall of a lot of green infrastructure, is the maintenance. And I actually wrote a manual on maintenance that I will send out probably at the end of this series, just to give you an idea of what goes into the maintenance for these different green infrastructure features. So that's really something critical to plan ahead for. But so 20 to 25% lower maintenance, energy, and environmental costs are estimated over the lifespan of a green roof. So that's 30 to 50 years if proper maintenance and proper installation is in place. And so that's a really significant amount of energy, lowered maintenance and costs. And the green roof can extend the life of the roof structure. So it can extend the life of that waterproof membrane on a roof that's going to need to be there anyway on flat roofs. Green roofs can also reduce indoor temperatures by 3 to 4% during the summer, and that results in savings of 15% or more. They also reduce stormwater runoff by anywhere from 40 to 80%, depending on how much the roof is covered over the lifespan of that roof. So that becomes a significant environmental impact and economic impact. But it is difficult to quantify unless you're specifically taking data on that environmental impact over the lifespan of a roof. It is kind of difficult to quantify the specific dollar amount that reduction in stormwater has, but it is significant. You can imagine over say 25 years how much stormwater would be intercepted by a roof if it were somewhere close to 80%. Whoops. There we go. Okay, so the kind of rough estimate, over 25 years, a green roof can reach 100% return on investment, and a lot of times even go into the positive net gain side of things on that investment. So over the long term, they're a positive net gain investment. And annual maintenance costs, just in a general estimate, is somewhere between 75 cents to $2 per square foot of green roof, depending on, again, the system, what's there, if it's extensive, intensive, somewhere in that range. All right, so now we've got some resources here, and I think the video is last. Okay, so resources that will be emailed to you. Cities Alive is a non-for-profit in Canada, and they hold one of the biggest green roof, green wall, and green infrastructure conferences each year. They're a great organization, and their website has a lot of great information on it. Again, I mentioned that urban heat island effect study. This is that study from the EPA that was done on the Chicago City Hall green roof. This is another great resource just on all information about green roofs through the Green Building Alliance. And then if you're interested, this is my master's degree research that I did on the green roof, the comparative fertility evaluation for peppers and melons. And so I think you can at least look at the abstract for it. I think you may have to pay to see the whole thing. And I don't get any, I don't get any compensation for that. That's through the ProQuest. So that's just how academics works. But if you're interested, feel free to take a look at that as well. And then we'll check out our video here. So this video, I think it's the quality of it isn't the best, but if anything, the information that we talked about is useful here. So we'll check it out. Okay, greetings all of you green roof guys and gals joining us today for the Greening Up series on green roofs. I'm Austin Little, U of I Extension horticulture educator, and today we're going to be looking at the green roof here at the College of Agriculture at Southern Illinois University, Carbondale. So this is kind of the entrance here and the stairs that go up to the roof. We're going to have a look around on the roof today, kind of look at some of the different features we have up there and a bit of the construction and how it works. So let's go ahead and get up on the roof. All right, welcome you up here to the green roof, and this is a extensive green roof, and I do apologize for the noise today. It's a bit noisy, but we're going to go ahead. And so this is an extensive green roof. That means it's going to be pretty shallow. Extensive green roofs are typically only 6 inches deep, and this one is no more than 4 or 5 inches deep at the deepest points. But we have a few different sections up here on our extensive green roof that was installed in 2010. And so you can kind of see this aluminum edging here, and that's holding in the layered system, the layered medium with vegetation on top, drainage layers underneath, and this is all kind of bordered in these sections by our aluminum edging, and then we have these nice pavers up here, permeable pavers, and that's all over the top of the impermeable vulcanized rooftop membrane here that's waterproof. So there are different types of green roofs. Some green roofs are used more for amenity or for public access. Our green roof up here is really primarily for the ecological services that it provides, and it's kind of an open lab that we use for research, teaching, demonstration, and then we get the other ecological services from our green roof, such as water conservation, stormwater conservation, heating and cooling of the building, reducing the urban heat island effect, adding green space where there was just a built environment there before, stormwater reduction systems,
and we even use it to grow food. So green roofs are a space that can be used to add to space for urban agriculture, which I've got some research going on up here right now, and we'll talk about that in another video here. So now I'd like to kind of show you just some other sections of the roof and kind of give you a closer look at some of the plants that we have up here and kind of our layered system here. So let's go ahead and get in and see what we got up here. So the section that you're seeing right now is an area of the green roof that previously has been used for research, then was really just covered with sedum. So sedum is a great crop for a great plant for the green roof. It's very versatile, very resilient to the heat and dry conditions, and does well to cover the surface. So we get that evapotranspirative effect from the green cover, and kind of outcompetes other things and comes back every year. But this year we have some all-American winter varieties of tomatoes, peppers. We have echinacea, zinnia, marigolds, and even some coreopsis up here, some bearded foxtongue or foxglove, and all kinds of really neat little wildflowers up here. But the main kind of addition was we kind of added in some of this mulch pathway here to kind of give it more of a landscaped look and give us access. And so we kind of did an arch of tomatoes and peppers, of these all-American winter varieties of peppers along here that you can kind of see. They're not really fruiting out yet, but maybe we can come in here and kind of walk through here and look at what we've got. And as you can see here, we've got some tomatoes and peppers and a few kind of catty-cornered offset rows, and those will be really productive here, we think. And then over here, we can kind of see all of our cool zinnias and a couple different varieties of zinnias and marigolds up here as well. And our path kind of comes all the way over here. Now I think we'll switch back and quickly take a look over at this section here. Now it doesn't look like there's a lot going on, and if we look down here, we can see our drip tape working. So we water pretty much everything on drip tape on the roof. And so here we've got mostly wildflowers in this section, and you can see we've got right now what's really coming up are the black-eyed Susans, but a couple weeks ago it was pretty much all coreopsis. Now the coreopsis is kind of slowed down, and now kind of successional blooming is coming in with the black-eyed Susan. And we can even see a couple other things. There's a few little pink sedum flowers and dianthus coming up, so those are cool. And this is kind of a hodgepodge of things over here as well. A lot of different wildflowers in there. And so while we're here, let's take a closer look at, let me get out of the shot there, my shadow. So here is kind of a closer look at the GRM there, and we can kind of see the drainage tray. So that's a kind of a egg crate shaped kind of drainage tray that is underneath our rooftop, our GRM, that is going to help to hold on to water for a longer period of time, so that it can evapotranspirate and rise back and be pulled back up into the medium, because this medium does dry out pretty quick. So we need a way for it to have access to that water for a bit longer. And here we can kind of see some of our, now this is a wildflower, this is fleabane, and up here we kind of call it invasive because it is really aggressive up here, but it is a wildflower, so sometimes things are going to be a weed in some places, and other places maybe they're desirable. But what I wanted to talk about here was, to my left, we've got our research plots that I'm doing a research trial on. So that's one of the really cool things that green roofs can also be used for, is addressing urban agriculture and kind of increasing the amount of fresh, healthy, local food that can be produced in an urban environment where there's not a lot of urban space for local agriculture and community-supported agriculture. And so what we're looking at here is we're looking at looking at how quick compost breaks down in this green roof medium. So that's an important question, because we need to make sure that we're not overloading the medium with more nutrients that it can handle, and that we're not increasing the weight over time. So the previous thought was that maybe compost, cow manure, something like that, is going to break down each year. It's just going to burn up really quick, but that isn't always the case. So we need to see how quick different amounts of compost are breaking down within the green roof media, so that we know kind of a guideline on what to add in each year, and what's going to be the most effective without kind of overloading the system, overloading the nutrients and having nutrients run off. That's something we want to try to avoid as well. So we have a range of adding 20 pounds down to 5 pounds, and this is the second year of this trial, so we've got another video there talking about the data that we're taking from that as well. We've got our peppers. These are cayenne peppers that have been installed, so they're 2 peppers per plot. Now this research, again, that we're doing up here on the roof is looking at the breakdown, how rapidly organic matter in our ultra lightweight green roof media, or GRM, breaks down over time. So we're taking medium analysis every year to look at the rate at which organic matter breaks down at 6 different levels. And we've repeated the treatments 3 times, so we have 18 plots up here. So what I've done today is I've taken some data. So in addition to looking at the organic matter, we're also looking at how these cayenne peppers react to how they perform with varying levels of organic matter in the medium. So some of the data that we're taking, two main data points that we're taking are vigor rating, and the vigor rating is a visual rating on overall health and performance of the plant on a scale from 1 to 9. So as I take my vigor rating, I look at each plot and I take what I see as an average of overall health and performance of the plant. So for instance, this plot here, for overall vigor, I would say that this plant here is a 6.5 or a 7 on a scale from 1 through 9, but our adjacent plant here, our neighbor plant, is probably more about a 4 or 5, so I would probably average this out to a 4.5 for a vigor rating. So that's how we do the vigor ratings. And then we do another really interesting data point, and we use a SPAD meter for that. So this is a really cool little electronic gadget called a SPAD meter. And so what a radio spectrometer does, for this unit, it reads active chlorophyll, and it's got a little sensor in here, so it's a pretty non-invasive data extraction technique that we use to take a data point. And so what we look for is a nice healthy green leaf on our pepper plant, and we just lightly clamp down, and that gives us a reading between negative 9.9, which would be really low, almost no active chlorophyll, and all the way up to 199.9, which is extremely active. The general readings that we get for these plants are anywhere between the teens up to the 60s. So the way this device works is it shoots a electromagnetic laser through the plant tissue, and so it basically reads the amount of active chlorophyll that's going on in the plant. Plants with more active chlorophyll have a more deep green color. That's the color that they reflect, that green color. So that's a good indicator of active chlorophyll, and that's basically what this gadget does.
All right, that was our quick tour there and a look at some of our technical stuff there on the roof. And so let's go ahead and do a question and answer about green roofs. I think there's probably a few questions in there.
Yes, there is. So the first question was actually a question at the very beginning, and they were asking about a term that you said. I think it was albedo, maybe?
Albedo, right. So
yeah,
that's
they just wanted to know how to spell it.
Oh yeah, I think it's ALBEDO,
Okay.
albedo. And
All right.
that's just the reflective quality of surfaces. So the more something reflects solar radiation, the higher the albedo, which is good. You want more of that reflected but with built material.
All right. Okay, so the next question is, are most green roofs planted with native plants to replace what was lost and directly benefit the native insects? Also, I think I've heard that insects utilize these rooftops, meaning a top and above ground building, gardens. What about birds?
So the first part of that question was uh, the plant type. So it really varies. I don't know if most of them are, but a lot of them are primarily native plants. But in the cases of, so in urban areas, everybody wants green roofs for urban agriculture. That's kind of the leading use now for green roofs. And so in those cases, there's kind of a limited amount of native plants for food, and a lot of those need a deeper substrate anyway. They're going to be more perennial things if they're native trees, shrubs, and kind of herbaceous things like that. But kind of the things that we're going to be growing are kind of market vegetables and fruits. Those are going to be more in the extensive green roofs. So, those are going to not really be natives, but like in Chicago and a lot of their municipal green roofs, they do have native plants, a lot of native prairie type plants. And so another problem with the native plants is that they really kind of need a lot of them need a deeper substrate because they have really deep, naturally deep root structures. And they like to kind of burrow deep into the soil. So that's not really compatible for a shallow green roof. Now, if you have a deeper green roof, like a couple feet, you can do more of these native kind of plants, like the native wildflowers and grasses and sedges. There are some exceptions though with sedges and things like that. On our green roof, we have Coreopsis that is really well established, black-eyed Susan, the fleabane, which we're always trying to get rid of. But then we have like bearded foxglove and other things like that. So they adapt. They can adapt. It's just that primarily, the most common green roof cover for extensive green roofs is sedum, or Sedum kamchaticum, or some type of mix of sedum species. And there's a few native sedums, but most of them are non-native. They're not really invasive or kind of at risk of that, but they're used because they cover green roofs really well. They're shallow rooted, and they offer those benefits of recycling water, evapotranspiration, heating and cooling benefits, and all of that. Now, they don't have quite the same impact on pollinators, so that's one drawback of those. So there's some benefits and some drawbacks, but sedum is going to be the most commonly used for kind of just the ornamental vegetative ground cover. And again, that's going to be different for extensive roofs. So on extensive, yes, you would see more native plants. And so to the question of animals like insects, pollinators, and birds. So on a green roof like ours that's only one story above ground, then we don't really see a reduction at all. I see a lot of pollinators up there. We had a family of ducks that nested up there. But we're close enough to the ground that they can still easily access that. All the birds and insects fly that high. One thing we don't have in our extensive green roof are earthworms, and a limited bacterial and other beneficial insect population, because it just gets so hot and it's reduced organic matter, so it's not really conducive for earthworms. But on an extensive green roof, you would find a more biodiverse kind of soil ecosystem there. And so birds, in cities where some of these green roofs are going to be on, really tall skyscrapers, the birds that you would find up there are going to be things like pigeons, hawks, make nests up there, but kind of the lower flying birds maybe, wouldn't be up there. But geese are up there, those kind of things are up there. And so the pollinators on really tall green roofs or on high level green roofs, a lot of those have apiaries. So they're going to have bee boxes up there that they bring up in the summer and maybe keep them up there. So some of those, they don't fly that high, but on lower levels, you'll find a pretty diverse range of pollinators, butterflies, bees, wasps, birds, hummingbirds, even spiders and things like that are in abundance there. So kind of the range of insects are up there for sure. One thing I wish wasn't up on our green roof were squirrels. So if there was a way that we could keep them out, because they really go for melons. So it's hard for us to grow melons on the roof. But other than that, yes, there are birds, but the kind of more high flying birds are going to be on the taller green roofs. Okay.
All right, thank you. The next question, I'm just going to go ahead and read through this because they they put quite a bit. If you look in the chat box that's right there, I'm just going to read through it and then you can answer it. How and when are businesses approached about putting on a green roof? Is it something done as part of a permitting to build process? Is there any particular group that promotes green roofs? How expensive is it to reinforce an existing structure to place a green roof? Say if Walmart or Menards wanted to put one on, or what about McDonald's or Dollar General?
So a private business is probably not going to be approached by a green roof company. Well, they might be, they might be offered some kind of incentive, but typically a business or a corporation is going to take that initiative on their own to kind of improve their sustainability of their corporation. So corporations care about the public perception of them, and they want to be sustainable because that's what everybody views as important. And so they really do that to improve their business. And something like a box store, like a Walmart or a McDonald's or a store like McDonald's or Dollar General, that's going to be kind of an internal initiative. However, if they're building new sites, if they're building new stores and locations in certain cities, those cities have ordinances now. So something like Nashville over the past 10 years developed these citywide policies where any new construction has to mitigate and process a certain level of stormwater from their building. And if they don't, then they pay a tax penalty, or what they say is a fee, a stormwater fee, but really it's a tax penalty. So businesses want, because it's pretty expensive, and they figure instead of paying this fee, it's going to be cheaper in the long run for us to install green roofs and other kind of water retention green infrastructure on our buildings. So in that case, they do it to avoid that fee or tax penalty. But at the same time, these businesses get rebates and tax benefits from the installation of these infrastructures. So they'll say, we'll give you a tax rebate of however much if you build here, plus you install these green infrastructure initiatives. Nashville is one great example of that. So they've really done a lot there in those policies. But for like a private business that just wants to do a green roof, a lot of times there's going to be those tax rebates or incentives. There also may be grants that are available. So if it's like say a city apartment complex, there may be some kind of which a lot of apartment complexes feature green roofs, but those are more for the residents in cities. But there may be some kind of city, state, or federal funding there. Even for say a private residence, you may even find there to be some kind of city, state, or federal funding. So also buildings may be trying to gain or earn the LEED points to make them LEED certified. And so LEED is the leader in environmental energy, leadership in energy and environmental design points and certification. And now, while that isn't a direct monetary reward, what that does is it increases the property value, and it symbolically shows that you're kind of on the cutting edge of sustainable development. So, so these are all incentives for developers to go ahead and do this. But sometimes it's the policies of the city kind of influence them in a way to make them go ahead and adopt these green infrastructures. So I think maybe that was the first part of that question. So yeah, the groups that promote green roofs, the EPA, our city, state, and federal governments promote it. Green roofs, Cities Alive is a big promoter of green roof technology. Universities. So there's a lot of different entities out there promoting green roofs in the United States. And so how expensive is it to reinforce an extensive green roof? And so that's the most common type of green roof, is extensive, and they're retrofitted on older buildings. So I mentioned LEED certification. New, like cutting edge, the most modern, high-tech buildings, all of the LEED infrastructure, green infrastructure on those, they're so efficient now. The materials are so efficient that what's been shown is that the green roof doesn't really impact the energy cost so much, but it's more you still get the rain, the stormwater reduction and recycling benefit there, and the green space, pollinators, biodiversity space for green agriculture or urban agriculture. But the energy cost has now been basically a moot point because of how efficient those buildings are. So with it, so to answer that question, it's really going to come down to how much reinforcing the building needs, how old the building is. It's just going to really vary pretty widely. I don't really have an exact number for that. It's just going to depend on the specific case, you know. So in the case of the SIU green roof, it was a $40,000 project, and some of that cost was reinforcing the roof, but I don't know what part of that was. So I think that answers that, I hope.
All right, and if it did, that's yeah, they said thank you. That is the last question that we did have.
Okay, awesome. Well, thanks for joining us again today. And next Friday, we'll be looking at green walls, and we'll do a tour of the green wall at SIU. And I hope to see you then.
All right, thank you. And just a reminder that I did just email out that evaluation, and it has the links. And I think there was maybe one more thing we had to email out, but I wasn't sure. But look for that evaluation.
Okay, thanks, Maggie.
Thank you.
Okay, have a good afternoon.